This is mathheals.com, and you can go here to get more links to YouTube math videos if you wish. Let's take a look at some summary of factoring techniques. So let me write them down. For factoring, our first method is GCF, greatest common factor, and I'll put an asterisk by it. You always try to do that. Our second method is grouping. And this is when you have 4 or more terms. Third one is the Psd method, and this is when it's of the form x squared plus bx plus c. Our fourth method is the key number, and that's when it's of the form ax squared plus bx plus c. The fifth method is dots, difference of two squares, and that's two terms with a minus between them. So two terms with a minus between them. And then our sixth method is the difference of two cubes and that's two terms with a minus between them. And then our seventh method is the sum of two cubes, and that's two terms with a plus between them. Now this section revolves around using these different techniques, and you have to figure out which one to use. They don't tell you that anymore. And we'll also introduce a new technique. It's called the U-Substitution. Let's look at our first problem. We've got 3x to the third minus 75x minus 5x squared plus 125. First method is GCF. But as I look at these, all four terms don't have anything in common. Some are divisible by 3, some are divisible by 5, some of them have x's, but not all of them. All four terms have to have something in common for you to factor it out. So we start going through our list. Second method, grouping. 4 more terms. Well, this is 4 more terms. So let's group the first two together and last two together. Now look at my first two terms. The GCF of those is 3x. And that gives us x squared minus 25. Now looking at our last two terms, GCF of that is they both divisible by 5, and my first term is negative. So I'll factor out a negative 5, and that gives us x squared minus 25. Now our goal with grouping is, again, to get this parentheses the same as that, which they are. So I'll factor that out in front. And that leaves us 3x minus 5. Now 3x minus 5 we're done with. But this over here, if we start going through our list, PSD, no. Grouping, no. Difference, two squares. Two terms with a minus between it. Two terms with a minus between it. That fits again, doesn't it? So this first one is grouping. And this is going to be dots. Difference, two squares. So we'll take a look at our first parentheses, and we're going to try to write it as something squared minus something else squared. 3x minus 5 just carries down. We ask ourselves what times x, shouldn't think of the answer. What times itself gives you x squared, and that's x. And what times itself gives you 25, and that would be 5. Remember our formula for difference two squares. You take what's inside your first parentheses, you add what's in your last. You take what's inside your first, and you subtract what's in your last. And then the 3x minus 5 will carry down. And we can't break that down anymore, so that's our answer. Let's look at our second problem here. We got x squared minus 15xy plus 54y squared. First method, GCF. All three terms don't have anything in common. Second method, grouping. Well, that's when you got four or more terms. This is three terms. Psd, x squared, x, and no number in front of the x squared. Well, that fits. Again, that's what we focus on. The x squared, x, no number for the x squared. So at the Psd, we take our number at the end, the 54, and we're going to come up with our three columns. The P stands for our product. We list all the products, give us 54. There's 1 times 54, 2 times 27, 3 times something, 18. 4, no, 5, no, 6 times 9. The S column, we're going to add these together, S for sum. 1 plus 54 is 55, 2 plus 27 is 29, 3 plus 18 is 21, 6 plus 9 is 15. Difference column, D for difference, we subtract them. 54 minus 1 is 53, 27 minus 2 is 25, 18 minus 3 is 15, 9 minus 6 is 3. Now the number we're looking for is a number in our middle term, which is 15. We got two 15s. And when you got a positive on your last term, the only thing that'll give that to you is when you have the same signs. So we want this one here. But again, if you're not sure, try one, see if it works. If it doesn't work, it's the other one. When I say see if it works, multiply it back through and gives you the original problem. So let's put this in here. We got 6 and 9. So put 6 here, put 9 here. Doesn't matter, you can put 9 here and 6 here. Now remember our note on our signs. The larger number in your P column is always the same sign as your middle term. Middle term's negative, so this will be negative. If the number you circled is in your S column, S for same signs, both positive, both negative. If the number you circled is in your difference column, D for different, so you'd have different signs. One's positive, one's negative. Well, the number I circled is in the S column, so same signs. So if this one's negative, this one has to be negative. Now how we handle that extra bit is you put a y on like that. And that's your answer. Now nothing special on that. X squared, x, no x, and we have x and x. Going backwards, y squared, y, no y, and we have y and y. So that's all of the changes on that. Other than that, you do the Psd method like normal. Let's take a look at this one. We got 80 x squared, y squared, minus 2xy minus 1. This is going to show the U-substitution. Now, first step. Let the variable part of the middle, so let the variable part of the middle be U, and the variable part of the first be U squared. And if that don't get any more vague than that, I don't know what. Let's see what that means. Variable part of the middle. Well, that's excluding the number that's in front of it, the coefficient. So we're going to let this be U. And we'll let this be U squared. So this becomes 80u squared minus 2u minus 1. And now it's a quadratic. It's what we're used to seeing. Now, when can you use the U-substitution? Why did I even think that I could do this in the first place? Well, if you can take the variable part of the middle, whatever it is, in this case it's xy, and take it to the second power. If I do that, that gives me x squared, y squared. If that equals the variable part of the first, that's when you can do the U-substitution. Well, our second step, we're going to factor like normal. Well, this is, if I start going through my list, GCF, there is none. The Psd, or wait a minute, grouping, 4 more terms, that doesn't fit. Psd. That's close, but Psd says you have u squared, u, no u, and there's no number in front of u squared. Key number. U squared, u, no u, and there's a number in front of your u squared. Now I'm writing this over here, but this isn't actually part of the steps. This is the method I'm going to show on this. So I'll use key number on this. So we'll take the number at the beginning times the number at the end, ignoring signs. So we've got 80 times 1 gives us 80. Now they won't all be key number. So again, this has nothing to do with this particular step here. I just didn't have room to write it over here. Yeah, maybe I have room to write it below. Let me do that, just because I don't want you to thinking it's part of that. There we go. Let me do it down here. So we'll take 80 times 1, and that gives us 80. Again, this is key number. So I'm going to create the 3 columns. So I got 1 times 80, 2 times 40, 4 times 20. I'm writing all the products, give me 80. 5 times something, 16. 6, no. 7, no. 8 times 10. The S column, we add these together. 1 plus 80 is 81. 2 plus 40 is 42. 4 plus 20 is 24. 5 plus 16 is 21. And 8 plus 10 is 18. In the difference column, we'll subtract smaller from larger. 80 minus 1 is 79. 40 minus 2 is 38. 20 minus 4 is 16. 16 minus 5 is 11. 10 minus 8 is 2. The number we're looking for is a number in our middle term, which is 2, which is right here, which means I'm going to use 8 and 10. Now remember, with the key number, we rewrite our middle term using those 2 numbers. Now the larger number in our P column, which is a 10, is always going to be the same sign as our middle term, which is negative. The number I circled is in the difference column, D for different signs. So if the 10 is negative, the 8 is going to be positive. Well, then we use factor by grouping. The first 2 have a 10u in common, and that gives me 8u minus 1. Second group has nothing in common, but you always want to factor something out, so I'll factor 1 out, and that gives you an 8u minus 1. Well, they both have an 8u minus 1, so I'll factor that out, and that leaves me 10u plus 1. To see what goes in your second set of parentheses, you can cross off the 8u minus 1s. What isn't crossed out is what goes here. There we go. Now step 3. Plug u equals blank back in and simplify. And let me continue this problem down here. Now u equals blank, that's pretty vague. But you're going to find that every problem will be different. In this particular problem, we said u up here was equal to xy. So now where our u is, we're going to plug in xy. It's always wherever here is in the middle is what you plug back in. So this becomes 8xy minus 1 times 10xy plus 1. And that's our answer. And time to start a new page. We'll see more of those U-substitutions in this lesson. Let's see, number 4 here, we have 16x squared plus 68x plus 42. At least I think we will. Looks like one more at least. Okay, well, at least one more. Now this one. I start going through my methods. GCF. They have something in common. I'm not quite sure what. At least a 2. Maybe that's it. We factor out a 2. And that gives me 8x squared plus 34x plus 21. And 21 is 3 times 7, so that is actually all I can factor out. Now we're looking at what's inside the parentheses here. Of course, there's no more GCF. Groupings, 4 more terms. Nope, this is 3 terms. Psd, x squared x, no number in front of the x squared. Well, this one has a number in front of the x squared, so that doesn't work. Key number, x squared x, no x, there's a number in front of our x squared. Well, that's what this one is key number. So, we're going to take the number at the beginning times the number at the end. So 8 times 21. And that gives us 168. And let me grab a drink here. Okay, we're going to create our 3 columns. Our product column, we list all products, give us 168. There's 1 times 168. 2 times 84. 3 times something. I may have to get my calculator on this one. 56. 4 times something. How do I know this? I say 3 times something. Well, the shortcut for 3, for determining if it's divisible by, is if you add your digits together. 8 plus 6 is 14, plus 1 is 15. 15 is divisible by 3, so the entire number is. Didn't know what it was, but I knew it was divisible by 3. And when I said 4, if you take your last 2 digits taken as a number, like 68, if 68 is divisible by 4, the entire thing is. And that'd be 42. 5, no, 6. 6. Yeah. 6 times, let's see, that goes in there 2 times, 12, 48, so that gives me 8. 7, that'd give me 14, 28, yeah, 7. So 14 and 28 give me 4. 8 times 21. 9, don't think so. 10, definitely not. 11, no. 12, yeah. See, 12 goes in 16 one time. 16 minus 12 is 4, so 48, so this will be 14. 13, don't think so. 14, yeah. Oh, already got 14. Never mind. Kidding. The S column, I'm going to add those together. 1 plus 168 is 169. 2 plus 84 is 86. 59. 3 plus 56. 46. Boy, this is... I'm not used to ones that's this big. 34. Comes a sneeze. Excuse me. I kid my students sometimes that ask them how many of these they have to get right, and sometimes they say all of them. And I say, no, you just have to get the one right that you're looking for. We're looking for 34. And here's 34, so I'm hoping that's the... But let me continue. 53, 38. Shouldn't talk when I'm trying to subtract. I'll screw this up. Let's see, 22, 17, 13, and 2. Assuming I added and subtracted everything correctly, of course the number we're looking for is 34, which is right here. And 6 plus 28 is 34. So we're going to use 6 and 28. Now remember, we're going to rewrite our middle term using that number. The larger number in a P column we're using, which is the 28, is going to be the same size as the middle term, which is positive. The number I circled is in the S column, S for same sign, so if 28 is positive, then the 6 will be positive. Well, then I'll factor by grouping. 2 carries down, it doesn't change. First 2 have a 4 in common and an x. So that gives us 2x plus 7. Second group has a 3 in common, and that gives us 2x plus 7. Now our goal is to get this parentheses the same as that, which it is. So I'll factor out the 2x plus 7. And that leaves us 4x plus 3. And that's our answer. Now that problem is hideous enough as is, but if you didn't factor out the GCF to begin with and dive right in with the key number, you'd have 16 times 42, which would be some kind of huge number. Let's look at our next problem. we've got 2x to the fifth minus 162x. Start going through my methods. First method is GCF. And they both have a 2 and an x in common. And that gives me x to the fourth minus 81. Yeah. Now, looking at what's inside the parentheses here, I start going through my methods. 2 terms and minusing it, that's difference 2 squares. 2x just carries down, and I'm going to try to write this as something squared minus something else squared. Well, for the x to the fourth, you think what times itself gives you x to the fourth, and that's x squared. And now again, the shortcut for that is, if you don't see that, is you take whatever power is here and divide by this. 4 divided by 2 gives you 2. Now for the 81, that's 9 times 9. Difference 2 squares says you take what's inside your first parentheses, you add what's in your last. Take what's in your first, and you subtract what's in your last. Now the x squared plus 9 is done, but the x squared minus 9, that's the difference 2 squares again. 2 terms of minusing it. Specifically, x times x gives you x squared, and 3 times 3 gives you 9. So let me continue. So again, we're going to try to write it as something squared minus something else squared. We've already said x times x gives you x squared, and 3 times 3 gives you 9. This first part keeps carrying down. Now I'm going to take what's inside my first parentheses, I'll add what's in my last. Now I'll take what's inside my first, and I'll subtract what's in my last. 2 terms of minusing it, I think difference 2 squares again. But nothing times self gives you 3, nothing times self gives you x. So this is actually our answer. Yeah, let's see what the next problem looks like. Doesn't look pretty, does it? Let me start a new page. So I'll make sure I have room. This is problem number 6. We have 14 p squared minus 15 q squared plus 29 pq. Now, to begin with, this is in the wrong order. Standard form says you go from your largest power down to your smallest power, but you pick a variable to work with. Like you pick p's or q's. I'll pick p's. That means I need p squared first. I need p to the first power next, and then my no p at the end. So again, standard form says if I choose p's, I'd have p squared, p, no p. Now if I chose q's, I'd have to have q squared first, then q, and then no q. This one's easier to pick because the q squared has a negative number in front of it. Now GCF. Well, there is no GCF. I start going through my list. Groupings, 4 more terms. That doesn't fit. Psd. P squared, P, no P, and there's no number in front of the P squared. That doesn't fit. Key number. P squared, P, no P, and there's a number in front of our P squared. So that's what we're going to use as key number. Well, we'll take our number at the beginning times our number at the end. So I got 14 times 15. $210. And let me double check that. I'm not very good at multiplication here. 70. Yeah, 210. Now, don't panic about the difficulty of these problems. This is not like typical. Throughout college algebra, throughout the entire book, I don't think you run across one problem that has a key number this big. They usually keep them pretty small. The idea is you do harder ones here, and then when you hit the easier ones later on in other courses, intermediate algebra, college algebra, it's nothing. It's just like, oh, this is so easy compared to what we had to do. Okay, 1 times 210. 2 times 105. It's divisible by 3. The reason I know that is 2 plus 1 plus 0 is 3. And 3 is divisible by 3. That's times 70. 4. Last 2 digits have to be divisible by 4, taken as a number. And 10 isn't divisible by 4, so I know it's not. 5 ends in 0, so I know it's divisible by 5. Is that 42? 0, 1, yeah. And then 6, 18, yeah, 6. So it goes into there 21 3 times. That's 18. That gives me 30, which gives me 5. 7, definitely. 7 times 30. Now I know 35 minus 6 is my 29. I'm just trying to see how far I can go before I give up. 8. I don't think so. Just can't see it for some. No, 9. 18, 30. No, 10. 10 times 21. 11. No. I don't think so. 12. I don't think so. 13. I don't know. Anyway, if I was curious, I could go. Well, I got my calculator right here. I quit being so lazy. Okay, so 210, and I'll start at 11. That's where I kind of start fading. I can do pretty good up to tens. 212 divided by 12. No. 210 divided by 13. No. 210 divided by 14. No. Oh, yeah. 14 times 15. Ooh. That's also added together gives you 29. I wonder which one. Let's see. I'm going to go ahead and finish my table just for completeness sake. 1 plus 210 is 211. This is 107. Again, I'm adding these numbers together. 73, 47, 41, 37, 31. Subtract them. We got 209, 103, 67, 37. Again, the only one that's important you get right in terms of adding and subtracting is the answer. 23, 11, and 1. Ignore any addition and subtraction errors. You're merely sleepy. You're not actually seeing a problem. Well, our last term is negative. Well, that means the 29 I'm going to pick is the one over here in the difference column. So those are the two numbers I'm going to use. Now we're going to rewrite our middle term using those two numbers. Our larger number in the p column that we're using, which is 35, is always going to be the same sign as your middle term. So we're going to have a plus 35 pq. Number I circled is a difference column, d for different signs. So if 35 is positive, then the 6 will be negative. So we got negative 6 pq. Group the first two terms together, group the last two terms together. First two terms have a 7 and a p in common. And that gives us 2p plus 5q. Now my last two terms have a negative and a 3 and a q in common. So that gives us 2p plus 5q. Now our goal is to get this parentheses same as that, which it is. So I'll factor that out. So we got 2p plus 5q times 7p minus 3q. And that's our answer. Let's look at our next problem. This is another U-substitution. So we got x squared, y squared, plus 18xy, plus 80. Now remember with our U-substitution, we're going to let the variable part of the middle be u, and the variable part of the first be u squared. So this is going to be u. And this will be u squared. Remember, when you can use a U-substitution is if you can take the variable part of the middle here, excluding the 18, the coefficient. If you can take the variable part of the middle, square it, and it gives you this, that's when you can use a U-substitution. So we rewrite this as u squared plus 18u plus 80. That's step 1 in the U-substitution. Now step 2 is you factor like normal. Well, this is the Psd method. we have u squared, u, no u, and there's no number in front of the u squared. So I'm going to create a chart based upon 80. We got 1 times 80, 2 times 40, 4 times 20, 5 times something, 16. 6, no. 7, no. 8 times 10. Add them. 1 plus 80 is 81. 2 plus 40 is 42. 4 plus 20 is 24. 5 plus 16 is 21. 8 plus 10 is 18. Subtract them. 80 minus 1 is 79. 40 minus 2 is 38. 20 minus 4 is 16. 16 minus 5 is 11. 10 minus 8 is 2. Number we're looking for is a number in our middle term, which is 18, which is right here. So we use 8 and 10. So we've got u, and 8, and 10. Now our larger number in the p column, which is 10, is always going to be the same sign as the middle term, which is positive. Number we circled is in the s column, s for same sign, so if this one's positive, then this one has to be positive. Well, then our third step in the U-substitution is you plug u equals blank back in. Like in this problem, we said u is equal to xy. So we'll put the xy in for the u. So we've got xy plus 8 times xy plus 10. And that's our answer. And time for a drink and for a new page. So here we have 19n minus 21 plus 12n squared. And I want to factor this. And again, to factor, most of the times it's beneficial for you to put it into standard form. I would say all the time, but occasionally you have a grouping problem that it's not in standard form and it's already in the perfect shape to factor using that. Well, this isn't in standard form, so I need my n squared first. I need my n next, and my no n is at the end. So again, n squared, n, no n. First method, GCF. Well, I don't have anything in common. Second method is grouping. We've got 4 more terms. Well, we have 3 terms here, so that doesn't fit. Psd. N squared, n, no number in front of your n squared. That doesn't fit. Key number. N squared, n, no n, and there's a number in front of your n squared. That fits. So this is key number. Take the number at the end, or number at the beginning times the number at the end. So 12 times 21. And I'm gonna do some cheating here. I'm gonna use my calculator. I don't want to work that hard. And that gives us 252. Now I'm going to create 3 columns. 1 times 252 gives you that. 2 times something, and again, I'm going to be lazy. 252 divided by 2 gives us 126. 3, 5, 6, 7, yeah. 3 times something. Actually, I don't have to be that lazy. 84. 4 times 63. Yeah. 5, no. 6. 6 times 24. 2. Yeah. 7. I'll use my calculator. 252 divided by 7. Yep. 7 times 36. 8. 252 divided by 8. Nope. 252 divided by 9. Nope. Oh, yeah. I'm lying. 9 times 28. 252 divided by 10. Why am I even doing that one? 252 divided by 11. 252 divided by 12. 12 times 21. 252 divided by 13. 252 divided by 14. And 252 divided by 15. And it looks like that would be about it. Okay, so let's add these now. 1 plus 252 is 253. 2 plus 126 is 128. 87, 67, 48, 43, 30, 37. Usually I can do basic math better than this. This is pitiful. 32. Subtract them. That gives me 251. This gives me 124, 81, 59, 36, 29. Of course, we know the only one we have to get right is the answer. Watch me screw up that one. 4. Okay. I see a 19. That's promising. So here's 19, and here's 19 in our list. So we're going to use 9 and 28. And again, with the key number, we rewrite our middle term using those two numbers. Our larger number in the P column, which is a 28, is always going to be the same size as our middle term. So we have plus 28n. Number I circles in the difference column, D for different signs. So if the 28 is positive, then the 9 will be negative. Then use factoring by grouping. First two terms have a 4n in common, and that gives us 3n plus 7. Second group, first term's negative, so I know negative comes out, and they're both divisible by 3. So that gives us 3n plus 7. Well, now they both have a 3n plus 7, so I'll factor that out. And that leaves us 4n minus 3. That seems weird. 12n squared minus 9n. Sure enough. Sometimes, what always surprises me, sometimes you'll have the hugest number over here, like 252, and you come up with something that's very small, and you're sitting there, whoa, how'd that ever give me that big number to begin with? Okay, let's look at our next problem. And which happens to be our last problem. Got negative 100x minus 5x to the third minus 45x squared. To begin with, I notice this in a wrong order. Standard form says largest power has to go first. So my largest power is negative 5x to the third. Then our next one would be x squared. And then the x is at the end. So wrong order. First method is GCF, and I notice they at least have a negative in common. So first term is negative, so I bring out a negative. They're all divisible by 5, so I bring out a 5, and they all have 1x. Negative 5 is gone, that leaves me x squared. Negative 45 divided by negative 5 is a positive 9x. Negative 100 divided by negative 5 is positive 20, and that x is gone. Now looking at what's inside the parentheses now, this is Psd. X squared, x, no x, and there's no number in front of our x squared. So with Psd, I take my number at the end, which is 20, and I create my three columns. I write down all products, give me 20. 1 times 20, 2 times 10, 4 times 5. The S column, I add them together. 1 plus 20 is 21, 2 plus 10 is 12, 4 plus 5 is 9. In the difference column, I subtract them. 20 minus 1 is 19, 10 minus 2 is 8, and 5 minus 4 is 1. Number we're looking for is a number on our middle term, which is 9. So I'm going to use 4 and 5. Now, our larger number in the P column that we're using, the larger number, which is 5, is going to be the same sign as the middle term, which is positive. The number I circled is in the S column, S for same sign, so if this one's positive, this one has to be positive. And that's our answer. And the end of that section.